Hello everyone. In this video, I am going to talk about Chapter 9, Section 9.2, Composite Bodies. Basically, 9.1, we learned about how to calculate the center of gravity centroid of a shape in general. So in this section, we are going to look at some geometric shapes that is going to be a combination of rectangle, square, triangle, semicircle, quarter circle, etc. Anytime that we run into a hole, we're going to do negative area, negative volume, depends on the problem. So problems like this, we are going to divide our body into pieces that we already know about the shapes. If you run into holes will be negative area, negative volume, etc. We're going to combine them. We're going to combine those shapes, combine the triangle, the square, the circle, shapes that we already know, and then subtract the holes. And then strongly recommended putting your calculation into columns, rows, into tables. It will help you track which steps, which element that you're calculating right now. It will also help you to check if there's any mistakes and error that you run into. It will help you easily organize your data. Afterwards, you plug in the formula as we mentioned in section 9.1. Let's take a look at some examples together. I want to talk about this problem right here in 2D first, and then we'll go back to our 3D problem. This one right here, if I wanted to calculate the centroid of the part, overall it's a sort of a complicated shape, but however, we can divide our shape into shapes that we can divide this geometric shape into shapes that we already know. Part A is going to be a triangle, part B is going to be a square, part C is going to be a quarter of a circle, and part D is a semicircle, and part D is a hole that we're going to subtract. So overall, our body is going to be A plus B plus C, and then minus D. We are going to put our data into a table, and let me show you how this table works. Let me borrow this diagram here into our next slide. That way I don't need to keep toggling back and forth. What we have here is starting with the first row. First row is we're running our calculation for our triangle. So the area of the triangle, we know that the area of triangle is going to be 1/2 base times height. Base and height in this case, they are both 3. So 1/2 times 3 gives me the area of the triangle. And then the next two columns shows you the x and the y coordinate of the centroid of the triangle itself. Remember, we talk about the centroid of the triangle, it needs to be 1/3 from the base and then 2/3 from the top. So 3 inches total, that means I will have 2 inches on the left side and 1 inch on the right side. This refers to along the horizontal direction. Now be careful over here. Yes, it's 1 inch from the base, but the coordinate needs to be the actual location, the actual coordinate, actual location of the coordinate on the relative to the x and y axis. So the base of the triangle is 3 inches from the origin. That means the x coordinate, that means the x coordinate of the triangle, it will be 4, and it's negative because we're on the negative side of the x-axis. So that's where that -4 comes from. It's 1 inch from the base, and that base is 3 inches away from the origin. So it's -4 total. Y is above the line. Y on the y direction is above the line. We'll do the same thing. 1/3 from the base, which is 1 inch, and then 2/3 from the top, which is 2 inches. Okay, so that is going to be 1 inch from the bottom. Okay. Next thing, next two columns is going to be you do x bar, so the coordinate of x times the total area. So this one times this one will give me this column. And then if you do this column times this column, that will give me this one right here. Okay, so that is your triangle. Rectangle, we're doing it similarly. Similarly, the rectangle, the centroid, it will be right here. The area is going to be, because it's a square, 3 times 3. Okay, area is going to be 9. And then the x coordinate right there in the middle. So we have 3 inches total. That will be 1.5. And notice that right, 1.5 is in the middle. Notice that it's on the negative side of the x-axis. That's why it's negative 1.5. And then the y value right there in the middle, it will be 1.5 as well, but it will be above the horizontal axis, positive 1.5. And same thing, that one times that one multiply gives you this one. Notice is negative. And then the y, you do the same thing. That one times that one gives me this one. The next row, it's not empty, it's not a line there. If you download the actual PowerPoint file, they just made this font so tiny. You can blow them up yourself if you're interested in what they wrote, but I'm going to show you how I will do it. Next one, I'm going to change your color to red. We're looking at the quarter circle. It's this one right here, our part C quarter circle. The area of the quarter circle, we know that it's going to be 1/4 times pi r squared. And the r in this case is going to be 3 squared. You may put it in the calculator yourself. The x and the y axis for the coordinate for the centroid, you may look it up from the back of your textbook, but really it's going to be 4r time divided by 3 pi for both the x and the y. So 4r, our r is radius is 3 divided by 3 pi. 4r divided by 3 pi for both of them. They will be both positive because they are sitting at the origin. The center of the circle or center of the quarter circle is sitting at the origin. So both of them will be positive. Okay. I trust you putting that into the calculator yourself. And then now the next thing, that one times that one will give me that one. And then that one, let me use star because that's what I used before. That one times that one will give you that one. Okay. And then the semicircle is going to be a hole. So the first thing, the area is going to be negative. Let me use a different color actually. The area is going to be negative. Let me use purple. Negative area in semicircle is 1/2. 1/2 pi r squared. So pi times r squared. The r there is 1 inch, I believe. It's kind of hard to see because I've been writing over it. So 1/2 pi r squared. And then the next thing is the x coordinate right there in the center. You may look it up from your table. It's going to be a 0 because it's in the center of that half circle is right at the origin. So that's why your x-axis is going to be 0, and your y coordinate for the centroid will be the same. It will be 4r times 4r divided by 3 pi. So the r here is going to be 1 inch divided by 3 pi. And we're going to do multiply. That one times that one gives me that, which is 0. And then you do that one times that one gives me this. And notice that it's going to be negative. And then we're going to put our number together vertically. So this one, this column, add all of them add together. Notice that the last purple one is negative. Punch that into the calculator. You get a number a little under 19, 18 point something, and we round it up to 19. And you do this one, add all of them together. Okay, carry the sign with you. Add all this one together, carry the sign with you. Okay, so we put these three number that we're interested in on the last row together. And then we plug into our equation to get the coordinate x and y coordinate of the centroid of this complicated geometric shape that is made up of triangle, square, half a circle, semicircle, etc. I will also want to talk about another problem in 3D, which is this one. This problem right here, we are going to look at triangular prism, which is A, and then rectangular prism, which is B, and then another triangular prism C. Now, um, so over here, what we have, volume, we're going to calculate the volume. Row number 1, we're looking at A, the triangular prism. Volume, you have the um, area of the triangle, 1/2 times, I'm looking at the A, so I'm showing you where this one comes from. 1/2 times base, which is 1.5 meter for that A, this portion, 1.5 meter, and then times the height, which is 1.8 meter. 1/2 base times height, that's the area of the triangle. And then since it's going to be in the 3D prism, and then we're going to times multiply by the thickness of the triangular prism, which is another 0.5 here. Okay, so put that together, that will give you the volume. And then the x coordinate for the location of the centroid, and we'll just look at that. Along the x direction, which is this part, along the x direction, we have 1.5 meters on that triangle. And remember, we talk about triangle, it's going to be 2/3 from the top and 1/3 from the base. That's going to be 1.5 meter from the base and 1 meter from the top. Now, why is this 1 meter? Notice that the triangular prism does not start from the origin of this XYZ axis. You're still needing to add that zero point 0.5 meters. So that triangular prism starting from zero point 0.5 meters on the x-axis, starting point is zero point 0.5 meters away from the origin. So that's why the actual location of the coordinate, remember we do 1/3 from the base of the triangle. So it will be 1/3 of the base of the triangle, which is zero point 0.5, plus the distance from the origin, which is another zero point 0.5. So zero point 0.5 plus zero point 0.5 gives me 1 meter. So that's x-axis. Along the y-axis, we know that we're looking at this zero point 0.5 meter, and that's it. Okay, it's not on that direction. It's the thickness of the triangle. So it's half of that zero point 0.5 meter, which come out to be 0.25, which is that's 0.5 times 1/2. And then along the z direction is we're looking at the triangle again, 1/2 from the base. The total height of the triangle along the z directions is 1.8 meter. So 1/2 from the base. So not 1/2, 1/3 from the base, 1/3 of that 1.8 meter is going to get me 0.6. That's where that comes from. And then we're going to do multiply that one, this one times this one will give me that one. And I will do this star, that one times that one, all of them multiply by the volume. And then the last one, I will do a triangle. That one times that one gives me this one. Okay, so multiply each single one of them, XYZ coordinate, multiply by the volume gives me the next three columns. Um, B is relatively easier. It's a rectangular prism and it's starting from the origin. So you just do half of the thickness for each side for the B. Okay. And then C is another triangular prism. Just be careful that it's not starting from the origin. Whenever you calculate along the y-axis, right? The coordinate of the y-axis, don't forget to add how far is it away from the origin. In this case, it will be whatever that you get from the y, you need to add this distance as well. So for the y, it needs to be so half plus 2 meter. So there's 2.5 plus another 1/3 of that 1.5. So another 0.5. So together that will give you 3 meters. That's the y. That's where that 3 meters comes from. So 0.5 plus 2.5, that gives you the 3 meters. So be careful. And then z-axis counting from the bottom, that will be the same as the A, okay, counting from the bottom. And then along the x-axis would just be half of the thickness, which is half of this much. This much is 0.5 meter up here. And then half of the 0.5 meter is 0.25 meter, that one. And then you do multiplication to the volume, the three columns, every single one of them multiply by the volume. And then we're going to do our addition vertically. Vertically, we'll do our addition. Since there's no hole, all of them are positive. Add all of them together, every single one of the column. And then the last row, numbers in the last row is what we're interested in. We're going to put it in the number on the last row. We'll put it in our last table, and we plug into our equation to calculate the actual coordinate for the x, y, and z. Okay, so that's all I want to show you in this video, section 9.2 of our textbook. Thank you all for watching.